Hey, Kenred. How's it going? Hopefully, I have a fan going. The dehumidifier fan in the bathroom right next to my office, so it hopefully isn't screwing up the audio too bad. Let's refresh that chat. Well, okay, your chat's still technically there, but sweet. All right, that's just to fill up chat, so it's easily visible on the screen here. Yeah, let's. I think we're about ready to get started. Let me take off this thing. This. Okay, that looks good. I saw that you were streaming, I guess it was yesterday probably, doing some... You have 20 minutes of PC time right now? Yeah, it looked like you were doing Crystal. I'm not actually familiar with Crystal. Let's see, what am I doing? Let's go here. Here. Me neither. Nice. So trying out new things. Finishing our priority queue in Rust today. Live on twitch.tv/metame. Okay. Come keep some men's with us. Okay. I think that's good. Never wrote Ruby, so it's something really new. Yeah. I literally have no context for what it even is. Is it a language? Crystal programming language. Okay, so it's the whole natural language syntax like Ruby, which I'm also not super familiar with. I've written, you know, a few dozen lines of Ruby just once probably. But it has a static type system. So it's like Ruby syntax, low level, statically typed. Okay. Cool. Green threads, okay, yeah. Very reasonable. Yeah, lots of type inference, right? And then CFFI. Cool. All right, interesting. Good to know about. Not surprisingly, I can be a little bit of a programming language nerd when I have the time to, you know. I'll just leave this up here, and we can switch to code. I just realized I don't have any water on me at my desk, so I'm gonna go grab some water, and then we'll get into some code. This is definitely Messy Room Sunday. I didn't even make my my office bed in here. I didn't do very much. There's quite a bit of mess. So I spent my morning cleaning other parts of the house, not this room. So it's definitely messy. All right, I have a soda, but that's not very hydrating. So I'm gonna go grab some water. I'll be right back. Yeah, ADHD much, right? Hard to tell. Hard to tell. Okay. So we started our heapify down and we were in the middle of it, and then I realized I did it wrong. And I had a hard stop, so we couldn't fix it. So at first I was just comparing like left and then comparing right, and then I remembered that's wrong. We actually need to find the min child, and then once we find that min child, we swap it with parent. Assuming that the min child is actually less than parent. So we shall see. What I don't remember is how some of the conditionals work with optional. And I don't know for sure how I want to deal with that. We could just do 2 match statements. I guess let's just start with a match statement. Rather than having some like, hey Nightshade, thanks for dropping in. Hanging out, dude. Getting our priority queue done. So Prime will hire me. It's a little inside baseball Prime joke, right? But yeah. Hey Vivax, how's it going? Welcome. Glad you guys could drop in. We're almost done with our priority queue. Doing some drawing. Cool. Very cool. Yeah, in Prime's DSA course, he says if somebody just mentions the word priority queue in an interview, he would hire them. And he's like half serious. It's a half joke. Anyway, pretty funny. It makes sense. I mean, I think a Min Heap, a priority queue in general, whether it's Min Heap, Max Heap, it's a cool data structure. Probably one of the more practically useful things that we may or may not have already built for us in Rust. I am pretty sure there is nothing like this built in Rust, like in the standard library. So it's good to know about. I'm sure there's libraries you could pull down, a crate that is, but yeah. Yeah, so instead of playing with like how does none compare to some T, that feels dumb. I'd rather just have like an explicit pattern match. Wow, that's awesome. Yeah, I'm so bad at digital art. I'm really bad at it. I mean, I'm not that bad at drawing on paper. I'm not great, but I'm not terrible. But digital art, I'm really bad at. I think I don't have the patience to sit in front of a screen and create something by hand that way. But yet I have the patience to write code. I don't know. I don't know what the difference is, but there's a difference. Yeah, that's awesome, man. Cool. I love it. Okay. I guess before we get started, I'll give you my favorite boomer laughing in the corner by himself tweet of mine from this week, which I actually came up with on Swalker's stream because it was just obvious, but this is it right there. I like that one. Yep. But yeah. All right. I thought it was funny. But like I said, I'm often the one, all right, I have previewed Vivax's art, and we will show it on screen now. Nice, man. Cool. I like it. Always fun to try out new stuff. Improve your skills. That whole thing. All right. And in case it's not clear, I'm the old man laughing in the corner by himself, which is often the case. Yeah. Anyway, let's see. We're heapifying down. When we call heapify down, we know that I exist, but I was still doing this q.get in order to make pattern matching nice. But I don't know if we're gonna keep that. We'll just leave it there for now. But let's see. I guess we can leave all of this here for now, and we might condense this more. So let's just start with a match on LR, and we're going to actually assign this to little min child action, and it's pretty simple. If we have some L and some R, we could do this one of two ways. We could do if statements here. I don't know if there's like a big performance cost. I mean, it wouldn't be big, but I don't know what the performance cost is to this. But we could say if L is less than, we'll just say less than or equal to. That works. Yeah, Kenran, sounds good. I understand it. I'm a dad too. I've got a kid. So yeah, enjoy. Thanks for dropping in. That looks so weird because of the inverse of the fat arrow for the conditional. It looks so weird. Okay, anyway. Yeah, so then we're gonna say some L, and then technically this is just if they both exist this way, then we know R is smaller, so we can replace that, and then if only L exists, there'd never be a case where only R exists because of how we fill out our tree. So if some, oh no, I did that right. Okay. If some L and none R, I could use an underscore. I just like using none because it's more expressive in my opinion when you're already matching on an optional. since I've already caught all the other cases, right? I mean, if there was a conditional on both of them that wasn't exhaustive, then I might want to do an underscore, but in this case, having none is exhaustive. Okay, so if there's some L and none that, then we're back to some L. Which I already see, I think, if I'm right, an easy way. Nope, wrong hand. Classic. Then we say none. If both are none, then there's no child. How about that? All right, so there's min child. So let's see, I think if I just change my conditional a little bit, we can make this, we can just fall down to, yeah, that's what I want to do. Let me think about it. Is there any drawback to this approach? I don't think so. I don't think it's really going to matter. But basically, I'm just going to change these. I could just change the. Okay, sure. We'll just do this. So if L is greater than R, then we'll say some R. Otherwise, regardless if R is something or not, we don't really care. So this actually goes back to what I was just talking about with the underscore versus none. In that case, we can just go to L, and then we reduce the need for this entire branch. Nice. A little bit terser. Let's see. Yeah, I think what I want to do is, even though it's pretty much only used in this one function, I still think it's nice just to have a left and a right. So we're gonna do that. Let's see if I remember how to type. Okay. I know I didn't specify my return type yet, but it's all good. And I didn't specify one of my arguments. It's kind of helpful. But that's okay too. Okay, so this is just going to be u size, and this is going to return an option and t. That should type check. Okay, looks good. And then we're gonna do the same thing for right. I knew I typed that wrong. I felt it very wrong. I don't know why I can't type today. Oh well. It happens. And then right is just I times 2 plus 1. Okay. Missing a parentheses, right? No, it's there. I times 2 plus 1. Yeah, that looks good. Those look correct. So now we can delete that. And This is just going to be self.write I meant to write left, but that's okay. And this is going to be self.write I. Okay, so now we have match self.left I, self.right I. And then we are looking a little bit nicer. I like it. Got the V. That's still an optional, but it doesn't exactly have to be, as in I know it exists. And we have the min child. Let me think if I have anything that's wrong about this. Oh yeah, I don't have the index. That's a problem. That is a problem. Okay, well, maybe I didn't want to do that. Because I need the index of left and right. Like, I actually need to know which one it is. Ah, crap. Okay. I mean, I could say left with index and right with index, but then that's, I don't know. It's just kind of annoying. What do I want to do? I feel like then I'm just like obfuscating even more. It's even another layer of indirection. Okay, give me a second. Yeah, I should have thought of that. That's what happens when I don't write things out. Is that I actually need that index for left and right in order to know what I'm swapping. So that's the only problem. Let me think about this. I mean, I still like a lot of aspects of this, but it's just the whole index thing that isn't working for me. So, how do I want to do this? I could change my little methods to be with index, and I could return a tuple, and I could do all that stuff, or I could just keep it all in this function. I think I'll probably leave those methods even though I currently don't use them. And like I'll still maybe I'll still use them. I don't know. We'll see. Let's just get it working. How about that? So let's just say right. Let's just say Ri equals let Li equals. Okay, so then from here, I could make these like static methods that hold this logic in them that like both things use. I don't know if that's necessary. I'm actually leaning towards the tuple syntax. I didn't think I would, but I think I am actually. So let's just do it. Why not? We'll just say left with There's a thing. What do they say? Left with index. It isn't that rusty, but oh well. We'll deal with it. Let li equals I times 2, and then this can just be li. Then we'll return li. Like that. Okay. Good times. And then I just need to return, here is going to be a U size, option T. Yeah, that's fine. Okay. So let's just do the same thing here. Let's see, I can probably do this a little bit faster. Something like this. And paste, almost. Paste. Almost. Maybe still a little bit faster than it could have been. Okay. So we have that. R underscore I equals I times 2 plus 1. Okay. Okay. Whoops. Wow. Why is this? Oh, I hit the wrong key. I was like, why is Emacs even slower than I expected it to be? It was a me problem. It was a skill issue. Okay. So now we have right with index and left with index. So then down here, we can do a tuple destructure. And say self.right. Might help if I type the right thing. With index from I. There we go, Emacs. You can do it. And R. Almost. Okay. So that should take care of our actual type errors. We just will have some unused vars. Alright, that looks fine. We have now typed this all out so we understand how it works. So let's get rid of this. And we're there. Dude, what is taking so many resources on my system right now? I feel like it's even worse than usual. Let me just check real quick. Let's see. OBS is just killing my system. That's not too surprising. That's not too out of the ordinary. Anything. This now playing Touch UI loves to eat memory. I don't even know what the fuck it is. But it loves to eat memory. Like, I mean, it's probably the touch bar thing, you know? But I don't know what it, like, I'm literally focused on Emacs. It doesn't have to be thinking about anything. It's just like, it actually could be a bug in VLC4, to be honest with you, which is what I'm running to play music. It's possible that it's not the Mac's fault, but who knows? Touch bars are a spawn of Satan. Okay. So we now have our min child. So what we should do here is say, we're going to return a tuple of CI and child. Okay. So in this case, it's just going to be RI and some R. And in this case, it's going to be LI and some L. And in this case, technically there's no index. It'd be nice to use like -1, but that's not gonna work here. So we'll just say 0. One of the reasons that that's definitely fine, first of all, 0 is never gonna be a child index, but also in our priority queue, 0 is actually just garbage data. So it's even more fine in this case. Okay, so we have CI and child. So we did that match. And now we're going to compare V to the children here. We could do this in one big match statement. Like, we could have done what we did before, just with keeping the LI or RI and done it all in one big match statement. I just felt like it was going to be ugly, so I didn't do that. So, I don't know. It just feels like it would be easy to get really messy. Okay, so technically this is here, and Let's get some white space between some of these things because I'm finding it hard to read. And sometimes, for whatever reason, white space helps in Rust for readability, which is like a new concept for me because in Clojure, which I do for my job, like you don't do extra white space for the most part. Like there's certain times, but they're kind of like few and far between that you'd have extra white space for readability. I mean, realistically, this would just be its own function, and that's also one thing. It's like if I'm having to add white space for readability in a functional language, especially, I would just put it in its own function. And maybe this should just be its own function. Min child with index. And then this is that. I actually really like that. We'll probably do that, but for now we'll leave it like it is. Because it would make our heapify down easier to read. I mean, some people like really long functions that just encapsulate the whole thing that you're doing. I don't know. I find it harder overall to maintain, as long as you have like locality, right? Like if I took, you know, min child with index and then I put that somewhere else, like it wasn't right above here or right below here, then yeah, that would suck. Okay. If min child is less than v, then we swap with min child, and that's not at all what's actually happening here. So let's go ahead and make that what's happening here. Let's just say, nope, not min child, it's just child. Okay. So we can start with deleting everything that would be you know what, actually I think I just want an if let here instead of a match. I think it's gonna be simpler. And then I'm not even gonna wrap v in an option. I don't have to do the self.q.get index I, because I know that it exists. So v can just be self.qi, like typical index access. Yeah, I think that's what I'm gonna do. I think it's gonna make this look nicer. So let's just say self.qi. And then instead of all this, I'm just going to delete this. And we're just going to say if let some nope. Okay. I thought I was waiting for it. I forgot to actually type it. If let some child, I didn't mean to put the tuple around it, parentheses around it. I don't know if I was thinking it was tuple or if I just was writing Clojure. Both are possibilities. Okay. If let some child equals child, then I have the child index. Oh, right. Ooh, yeah, I see that. Yeah, that's fine because it's a no op. It's a no op in the other case, so yeah, no, I think this is still what I want to do, even though we're going to have like a little nested if here. Because I don't think I can do, I don't think it's valid syntax to have an if condition here, like if let some child t if be, let's see, if child is less than v. I don't think that works. Is that valid syntax? I mean, that'd be like, you know, the match thing. Yeah, I didn't think so. I don't think that makes sense. Syntax error, expected EQ. Yeah, okay. Just making sure. Making sure I can't do that. Okay, so then we just say if child is less than v, then we are going to say self.q.swap. Can match do this in one step? It could. Yeah. So it might actually be nicer in a way as a match. Let me think. It would actually be one less line of code with the way I'm formatting this. So is it really worth it? Probably not. So kind of like I have 8 lines above Kinran, like I have a match on L and R. You have to handle failure manually. I'm not sure I know what you mean. It's just that I have to have exhaustive. Yeah, so like if I do a match, it has to be exhaustive. If I do an if let, I can just check one case. So in general, if I only want to check one case, I'm going to use if let. Like if I only really care about one case, I could do if let. So it's like I could write a match like this, and then the second thing would be else nothing, you know, and I would save one line of code. But I don't know. I don't know if one's more idiomatic than the other either. But it's my general sense that if I only have one branch to check, basically, then I'm just going to use an if let. If child is less than v, self.q.swap ci and I. And then we have to keep heapifying down. And in this case, we're going to heapify down. We're going down, so we know our CI is greater than our I, and we're going to pass it CI. And of course, our element at CI now is the same element that was at I before we started this. So that's where we're at. So this is saying V is technically like moved. So what I actually want to do is we'll just make this an and t up here, and then I don't have to think about it down there because I don't need the thing. Yeah. Dude, that's how meat goes though. You're just like, oh, this won't be that much. A 9-pound spiral sliced ham. That's a hell of a lot of meat. That's hilarious, dude. Well, nice, man. You got some ham to last you for a while. Great setup. Great setup, Nightshade. Clap. Okay. Yeah, and then if child is not less than v, and if there's no son, and if there's no child, then we don't even care, and we can just move on. Yeah, you're gonna eat on it for the next week, absolutely. Oh man, I used to love like a ham sandwich, like on rolls with like some spicy mustard or something. So good. So good with like the spiral ham. Yeah. Really good. Okay, I'm definitely gonna move this Min child. Yeah, spicy mustard, so good. A nice Dijon, or you know, depending on where you live in the world. Like, even an English mustard is really good. Oh god, it's been 20 years. But what's that English mustard that starts with a C? It's really, really tasty. They have a nice spicy mustard. But yeah, in general, over here in the States, it's much easier to get your hands on like a good Dijon. Oh yeah, Engelhofer. They have some good stuff. You can get away with that one. That one's gonna be pretty good. Yeah, for sure. For sure. Okay. So yeah, I'm gonna make a min child. A man child function. Alright. Min child, and I'm not going to specify that it's with index because to me it's not the same as saying left and then getting an index. I don't know, that feels a little bit weird, but maybe it's not weird. Maybe I can just get over myself and say, yeah, you know what, my left and my right, it fucking returns an index. Okay, all right, sorry, I got a little excited there. I think I'm going to do that actually. I like it better. This is my stream. I can do whatever I want. All right. I think I'm over my teenage antics there. So we're just going to say with index if I knew how to type, and we're just going to replace it with nothing. Yay. Hopefully there wasn't something else I said with index with. I don't think I did. Min child does not need a mute. I was just copying what was there. How about this? We're gonna make things easier on ourselves. We're gonna do a little bit of this, a little bit of that. Little D4, a little capital J, and we're in business. All right. And then all we need is a closing bracket, and we're good. Okay. So now what we can do is take all this mess. What is that? 9D, 9J. Okay. Yep, I think by calling the function min child, I might know that I'm trying to find the min child. I just have a feeling. I have a feeling that's the case. Okay, and then we're just gonna search for that little equals. That's the wrong freaking hand. And nice try. Nice try. What did I just do? I pressed the completely wrong set of keys. All right, there we go. Oh, actually, I needed it right here. Classic. Okay, and then we just need to get rid of our semicolon. Okay, min child looks good. And then all we need to do on heapify down. Let me just see. Yeah. Okay, we'll do that. We'll say CI, comma, Sum child equals self dot min child I. That actually looks pretty darn nice. I might know a little bit about writing Rust sometimes. That's not so bad. I think I'll just leave that there. Fake news. Yeah, it's fair. Don't worry. Don't worry, Nightshade. Pretty soon, I'll do something else. And it will be a lot harder than a priority queue. And I'll be cursing my skill issues. Oh, man. Okay, that's heapify down. I don't know if it's right, but that's what I'm writing. Okay, let's think through this. Let's look at where we're actually using heapify down. We use it in pop. I don't remember if I called it pop. I think it did. So let's think through pop before we test it. That way we can still consider it a first try. So pop, we're grabbing the root of our priority queue off. We're getting our min in this case. If there's nothing on the priority queue, then we don't do anything. If there's only one element on the priority queue, all we do is remove that one element. Otherwise, we get the end, the very last element that exists. We swap our current element with that element, and then we do a little self.q.pop back. I think that's fine. I could potentially try to like reduce the amount of actual like memory operations there, but I'm not going to. And then we heapify down. So when we heapify down, we just moved something to the top. We're supposed to be going down at each level, checking it against its children, seeing if it's less than them. We start with getting the min child. We know that it exists, first of all, at that index. That's important. So we could add that as a doc string. Panics if I is out of bounds. That's important. I'm pretty sure, let's see. Yeah, min child wouldn't actually panic if I is out of bounds, but that does. Which is probably a good thing, because then otherwise I'd have to like add handling for that in, and that should be like a case that doesn't happen. So it's a good time to panic. Anytime's a good time to panic though, right? Okay. Cool. I think I'm somewhat confident that it works. Let's find out. I think we're gonna go to just a single test for the whole data structure because it's just not that complicated. Not complicated means it's only probably taken me 2.5 hours to do this, which I'm sure would just absolutely pass a Fang interview. Well, if you have to use Rust for your Fang interview, then that's a problem. Probably, I think that's the problem. Anyway, but if you're applying to a Rust company, then I guess you might have to, right? Okay, so we have pq.push30. And why did I never create a thing that said... Did we never actually finish peak and I just thought we did? Like, am I crazy? Am I crazy person? Okay, that's all correct. I thought I had an assert EQ in here for that. I guess not? Huh. Alright. First of all, I actually want my debug print before that, because otherwise it wouldn't print out if that was false. And that's kind of the point. So at this point, we should have 30 at PQ peak. And then we're going to say PQ pop, and we should get 30 back. Start EQ, sum 30, PQ pop. Let's do our classic here. Okay. And then okay, that looks pretty good. Let's run it in our terminal. And change the test name. Oh yeah, I was gonna print it again. Oh well. Failed. Come on. You gotta be kidding me. Alright. Let's see. Alright. I kind of remember this happening before. So I push 30, and then I print it, and that's on line 121. And it has the right structure, 30, 50, 175. Oh no, it panicked. It panicked somewhere else. It panicked at pq.pop. So that means that the swap didn't ever happen. So why didn't the swap happen? That's funny. Okay, so this is a problem in our pop. It's not a problem with our peak. I was going to be really confused if it was a problem with our peak. Okay, so let's jump back into our pop and see what we did wrong. If self.len equals 0, none. If self.len equals 1, self.q.remove 1. Else, we have the end, which is self.len minus 1. That seems right. Self.q.swap 1 and end. That's the part that's very confusing to me as to why it's not working. We'll have to let's debug here. T is not debug, is it? Of course not. Why would you want to make things easy on yourself? Okay. That looks fine. Self.q.swap one with end. Self.q.popback. Self.heapify down 1. And just to make sure we're not crazy and didn't somehow mutate something else, let's just debug before and after the swap. Okay, let's try this again. What dumb thing did I do? Okay. So at 47, what? I switched? Cobb Coding. Hey, thanks for the raid. I really appreciate it. How's it going? Let me give you a little shout out here. Yeah, what were you guys up to? I don't think I was even following you before you raided me, so you are a new streamer to me. Building a VM in C? Cool. Very cool. That's fun. Neat. Any particular like use case or purpose? If you have time to answer. But yeah, that's neat. Yeah, absolutely. No, I appreciate it. Yeah, we were doing data structures in Rust. For a programming language? Sweet. Oh, that's really neat. So, yeah, like a programming language that has its own VM. Neat. Lots of fun. Well, that sounds very cool. I look forward to catching your raids, catching your stream sometime. That would be sweet. Yeah, for sure. For sure. Yep. I have been on the JVM for basically my whole career as far as people paying me to write software goes. Not necessarily all the things I would choose, but yeah, I currently write Clojure, which is nicer than writing Java for the most part, but you know, I've done Java quite a bit too, and the JVM hurts me. So, you know, but yeah, I mean, I think VMs are obviously it's a cool problem to try to solve. Very neat. Yeah, so welcome everybody. We have been working through a bunch of data structures in Rust over the last few weeks. We're currently on a priority queue, which is fairly simple. I say that, and I also have a bug in it right now that is an off by 1 error. Big shock there. I don't know why. I'm not sure exactly how I fucked it up yet. So we're about to find out. Like why my thought on this is incorrect. I'm not sure yet. So we'll look at that in a second. But yeah, we've done quite a few data structures already. I'll give a quick little tour here. You semi-rage quit Rust a while ago. Yeah, totally. Yeah, thanks, Cop Coding. Thanks again for the raid. Classic off by 1 error. This is my other classic off by 1 error. it was actually about availability, of course, and not actually an error. But yeah, little triple E meta me instead of quad E meta me. But oh well, you know, you just add E's until they let you do it. But yeah, TV Josh, thanks for the chat. Semi rage quit Rust a while ago. I get that. I've felt that a few times, as you can imagine. like I started working with Rust like quite a bit, probably about 3 months ago. It is my first systems language that I've really messed with. I'd say extensively, or you know, more than just a couple dozen lines of code or something. And before that, I've been in the industry about 10 years. I started kind of on the front end, quickly went into full stack, Java backend, and really found that I liked the backend more than the front end, and ended up getting a job. My second job in the industry was as a backend engineer writing Clojure, which is the job I still have now. I don't move around that much. So been at my current job almost 5 years, writing Clojure 98 to 99% of the time. For those that don't know, Clojure is a Lisp hosted on the JVM. It is a mostly functional language, despite using Java interop quite a bit. You know, not quite as abstract and nerdy and awesome also as like Haskell or OCaml, but you know, it still has a lot of nice functional concepts in there. So yeah, I've been wanting to learn Rust for a while, and I thought I started with contributing to some open source, and that was cool, and I learned a lot doing that. T-Gen mentioned, yeah. Like saying OCaml on a Haskell is literally the same as giving a shout out to T-Gen Pick, right? Yeah, I started contributing to open source, and that was cool. Learned a lot doing that, but decided I wanted to brush up on some data structures. I took the DSA course that Primogen did on front-end masters a while ago, and I thought, hey, you know what? Let's do the thing that I shouldn't do, and let's implement this all in Rust, because why not? And of course, with the borrow checker and all the different rules, the strictness of the language, it has been quite the adventure. So anyway, we've done an array list, we've done a binary search tree, we've done a linked list and a doubly linked list, we've done a queue, a ring buffer, and a stack so far. Isn't it hard to mutate two locations in the same array at the same time? Is it hard? It is using safe Rust. I would say the answer to that question is yes. I am like 90+% sure. You know, still only a few months in, but yeah. Unless you're using like a convenience function, like in our priority queue right now, you know, we have like a simple swap, right? But that's provided to us from on this collection that we're using, which is a vectq, which is a growable ring buffer actually. But swap also exists on normal vex, which is like an array list vector, you know, depending on what language you use. But we have done some unsafe, and it wasn't so bad. Of course, you guys coming from C, you guys are probably just laughing at me by saying it wasn't so bad. But like, here's our ring buffer, fixed size ring buffer. But we did, you know, we still only needed to pretty much just do one mutation at a time. Let's see. So there's our allocation. Where's our write? Yeah, okay. So this is just like the way a ring buffer works is you are overriding your oldest value with your newest value if you're full. And so that's what this little piece of code here is in this unsafe block. Yeah, absolutely. It's true. That's a great point, Hybrid Low. There are some helpers to help you do some of those things. So it's like you could get, let me think about this. Okay, so like as an example, on this array, on this ring buffer, I have an index mute implementation, which probably doesn't mean a whole lot to somebody that doesn't know what that is, but like here's index mute. And all it really means is that I implemented this for my own data structure, which is cool. But this is the same syntax if you were using like a vector as well in the language. And so like you can do R2 equals -45, and then of course on the next line R3 equals whatever, right? Like that's easy. But there's also some functions, kind of like Hybrid Low pointed out, like split mute and others, that will give you mutable slices, is what they call them, into a contiguous into contiguous memory, of course. And so those mutable slices they can't overlap, right? Because we can't have two mutable references at the same time. So that's kind of like the point of the mute split thing. But you could get a mutable reference to this part of your vector and a mutable reference to this other part of your vector, and do what you needed to do with them. So I don't know. Is it harder than other languages to do that? Like a little bit, probably, because you do have to care about the whole borrow checker rules, the whole part where you can't have more than one mutable reference to the same piece of data, right? But yeah, it's a great question, TB Josh. But yeah, welcome Raiders. I think we're gonna figure out this off by one error. I already see what it is. I just don't understand why it is what it is. So that's the part I'm not getting. But I just figured it out. I'm just dumb. No, that still doesn't make sense. Nope, I didn't figure it out. Just kidding. Did not figure it out. So I understand what it's doing. Let me just do this just to be overly verbose. Come on, Emacs, you can do this. I believe in you. All right, let's do this real quick. All right, that's what I wanted to see. Okay, so just to understand what I'm doing. Basically, the way that we have this working for our priority queue is that our first element in our underlying data structure, which in this case is just a vectec DQ, you could use an array list if you wanted to. I'm just using a vectec because it has O1 access on both sides. So it seemed to be the most efficient choice for what I'm doing. Because you need something that's both indexed and you need access to both sides in order to make this efficient. So yeah, a global ring buffer, is not a bad choice for something like that. Yeah. So anyway, the 0 isn't something that we've actually inserted into our data structure. This is just garbage data, basically. And that's just to make some of our index operations work. So essentially, I have that end equals 3. And I have that self.q.len equals 5. Oh, I see it now. I see it. Yeah. You get so used to doing this self.len -1 for arrays in similar, right? You're used to that for any zero based index collection. But in this case, it doesn't make sense. And that's because our length and our index, we kind of have to treat this as a one based index instead of 0 based index, right? And so that's the mistake I made. I didn't think through this correctly. So if I did self.q.len, and q is just our underlying vector, we'll just call it a vector. We know it's not exactly a vector, but we'll just call it that. Then that would have worked. But in this case, it's just self.len. So exciting. Okay, so we're just going to make this better, in my opinion, whether or not it's actually better, and we'll just pass self.len. And we know that exists. It has to. We also know it's not the same as 1. So we also know that. Yeah. Okay. Good times. That was the dumb mistake. Let's run those tests again, and we should be good. Let's see if we are. Let's find out. Okay, yay. Almost first try. Basically first try. A little off by 1 error. But that happens. Okay, so the last thing I want to do is just make sure that we heapified down that value correctly, because when we swapped, in this case 30 with 100, we want to make sure we did it right. Four medium to large Tupperwares left to Pam. Man, that's crazy, dude. That's so much food. All right, so let's just run this one more time over here so we can easily see the logs and make sure that our queue makes sense. Yep, 50, 75, 100. Yeah, it's valid. That is valid. Cool. So what we could do is just continue popping just to make sure that we didn't... Ideally, we'd probably have some more values on here to make this test more robust, but that's okay. So the next thing that comes off should be 50. And then the next thing that comes off is 75. Yeah, that's crazy, dude. That's a great deal. You know, sometimes life just works out at Nightshade, dude. And the definition of life working out is getting a fuck ton of ham. All right. Let's run that. Make sure it looks good. Okay, sweet. So that looks great. I think we can, I'll just leave the debug prints on there just because I think that's great. Let's just get none to return at the end. We know we got all of our, whoops, I didn't mean peak, I meant pop. Okay. Sweet. So that looks great. Now I just want to take debug off of our impl block because it's not actually necessary. And that's just here. Come on, you can do it. There we go. Watch out for that sodium. Dude. So I live in the southeast United States. We just call it the South, which I'm guessing people probably know even if you're not from here. Maybe you don't. Well, there you go. There's this thing called country ham, and it is the saltiest thing you've ever had in your life. Like, you're talking like you don't even have to refrigerate it. Like, if you go to the store here to get country ham, I mean, it's just salt preserved meat. It kind of makes sense, right? It's probably like super traditional, old school. But the point is, it's just like on a table at the store, and it's country ham, and it's basically just salt cured spiral ham. But you know, they have to do it in small enough chunks, right? You can't get like a huge ham. At least I haven't seen that. It's usually just like a chunk of spiral ham, though. You know, that sort of ham cut. You know, and it's just a hell of a lot of salt. It can be really, really good. But wow, the first time I had that, I was just like, whoo. Yeah, exactly. Salt needs to penetrate. Shout out to Java. Just want to give a shout out to Java, my original friend in the world. That's cool, dude. I wrote Java for 5 years before moving to Clojure, and I still have to write Java sometimes. We have a few things in Java. And of course, there's the whole Java interop thing. I mean, basically every single SDK that we use is all written in Java, right? So we have to use all the Java classes from that. This is true about Erlang. I know. I don't know if there's anything I really care about doing on my priority queue besides that. Like, there's not a whole lot else that you want in a priority queue. The main thing you want is, like, it's helpful to be able to see the next value without taking it off, right? That's our peak. Obviously, we have to construct it. You have to add values to it. That's pretty obvious. And you have to be able to remove values from it. And that's pretty much it. I think it would be cool. I don't really feel like I don't know if I'm going to do this, but I think it would be cool to create like a priority queue that has like a heap condition as a parameter. What's left for? I'll answer that question in a second. It would be cool to have the heap condition as a parameter. Like in this case, this is a min heap, but technically a priority queue more generally, right? Like your priority could be the return of any sort of comparative function. And so it'd be kind of like in Java, like taking a comp. I can't remember. I guess we'd probably, what would that be? An ORD, right? It'd be a partial ORD. But then it'd be like a comparator function that you could take as a parameter. And then it'd be like a generalized priority queue. I think that would be cool. I don't know if I'm going to do that, but I think it would be cool. Yeah, so left is just a helper function that we use down here. So Oh yeah, let me go to this little visualizer because I think it's really helpful. You guys can mostly see that. Okay. So here's our little min heap. Let's add something. Let's add a 30, which will jump back to the top. And let's just add something big. Just so it looks a little bit more complete. So when we heapify down, we need to know, we need to be able to calculate the children. And kind of like this shows, we actually just have an index-based data structure that's basically powering this tree. We don't actually create it like a tree, like we would like a binary search tree. So left is just a helper function for saying, how do I go from this node to its left child? But of course, generalized. Same thing. How do I go here? This is technically index 2. How do I go from 2 to my left child? So here that calculation is +1. Here it's +2. So obviously that doesn't work, right? So the calculation to get to left is actually just I times 2 is how it works out. So left says, give me a tuple back of my left index and the actual element at that index if it exists. So this is just a standard library function. We have this on most index collections where we can get an option back of the element at that index. So that's what left does. And then we have right, and then we use those in our min child, and then we just do a little match on them to see if the left child or the right child is smaller. Actually, that's what we actually care about. Which one's smaller? So if right is smaller than left, then we're going to return right. Otherwise, we return left. We don't even care about the right side here because the priority queue is always going to fill from left to right. So we already know right either doesn't exist or it's greater than left. So we can just forget about it altogether and just return the left. And then if none of those exist, then we just return none. And because that means that we're at a node like here or something. We don't have any children. So yeah, that's how that works. So then we use min child and our heapify down, and then heapify up, which we kind of did the visualization for already, is because when we first add an element, so let's add 45. It's going to add it to the next spot, and then it's going to move it up depending on its value. In this case, it added 45 here, and then it says, is 45 greater, or I mean, is 45 less than 100? It is, so let's swap out there. Now if we added 20, we get to see that happen a lot more because 20 is our min, and it's going to go all the way up. It's going to keep swapping until our heap condition is met. And that's how that works. Pretty cool. So let's commit this and push it. PQ. Finished. Priority queue. Yeah, if I would have just had like 2 hours to stream the other day, I would have like well, it took me about an hour to finish it. But I also mess around a lot. Get distracted by things. I mean, realistically, like focused on a whiteboard, I think you can knock this one out pretty quick. As long as you know how to use your underlying data structure. I mean, Rust gives us some nice things like swap, of course, and then of course the optional stuff makes the interface nice. But in any language, it's like you know how to write a swap. You know how to swap two elements in an array or you know, a list. You know how to do that. Rust just has some functions that do it for us. We could make some of the code simpler, but for the most part, I'm pretty happy with it. And even if I was whiteboarding this, I don't think I'd change all that much. I'd probably get it wrong, but I wouldn't change that much, assuming that I could actually do it. So yeah. Yeah, that's priority queue. God, I don't know what I want to do next. Ham is so distracting. Well, food's just distracting in general for me. Food is definitely my food is my first love, and then my partner. No, kind of kidding. Food is definitely like my brain's first love in the sense of like attention. So that's a problem. That's a problem sometimes. Learn Elixir to dunk on Winchester, but now he's like learning OCaml, right? And plus he doesn't follow me on Twitter yet, so what am I gonna do? You know? How can I dunk on somebody? He's yeah, I mean, what, I don't know what his problem is. No, I'm just kidding. Learn OCaml faster. I probably could. It's not a dunk on Ryan Winchester. It's just it's only because like I did quite a bit of Haskell a few years ago. That's the only reason I said that. I don't know Ryan's background totally. You know, I know he's been pretty hardcore Elixir for a while. This is what I'm thinking of doing. I'm not sure if I'm going to do this next because it's going to require a lot of work and a lot of me looking dumb, which is like kind of what this stream is all about. Yeah, it's his day job. Yeah, that's not surprising. I could see that. So it's kind of like me in Clojure. I mean, except that I can't say like a lot of people that I know that use Elixir as their day job language, they're like, this is the language. This is the great language of all. I guess a lot of people that use Clojure as their day job language probably feel that way too. I don't know. I don't. I really like Clojure, but there's a lot of things that I don't like about having to maintain Clojure apps. If I was just writing it and handing it off to somebody, then sure, like maybe that's okay. It's pretty fun to write, but like day to day. That's what I say about Rust. I'm biased, don't at me. Yeah. I mean, I really like Rust. I think it's been a lot of fun. This is what I'm thinking of doing next. Let's see if I can find it. Do you like that off-tune whistle? It's really good. I might actually do this next because I think I've played out a lot of data structures at this point where I feel like I've done most of the things that I want to do before graphs anyway. So I don't know. I don't know what I want to start with. I probably wouldn't do them in this order. I mean, maybe I should start with low level, because I'm still so far into like the Rust mind that it would kind of you know, I'd be able to like freshly compare them to using Rust, and that would be nice, because a lot of people, I mean, of course, you know, Rust is like, oh, systems laying that everybody can use, you know, whatever bullshit, you know, but marketing BS, but everyone can use it, but that doesn't mean that you can get it to compile. But yeah, I don't know. So maybe starting with low level and just doing like, this is like really high level, but you know, like can't use Rust, skill issue. It absolutely is. But doing like, it ended up being like a day or two in each of these languages, basically. That's what I'm thinking of doing next. I don't know if that interests anybody, but I think it'd be kind of fun. It'd give me a chance to go through a bunch of languages, and then like in November, and then in December, I'm struggling with what to do in December, because everybody here, let's go. I don't get to use this view very much, so since I'm talking and I look terrible, since I haven't got my hair cut or my beard trimmed in a while, we'll just go with my face being way too fucking large on the screen. But what I'm thinking of doing is, oh yeah, that was my thing. More than 1 month ahead. This is rare for me, TV Josh. This is very rare. Like me planning things out more than 1 month ahead, that doesn't usually happen. The only reason I'm thinking about it, he finally realized nobody redeemed first. It's there. First, by the way. An hour and 40 minutes in. Hilarious. What was I gonna say? Oh yeah, so like the whole thing, of course I have auto switch on, so it's just gonna switch over here. It's fine. You don't need to see my face that large anymore. Everybody does Advent of Code, of course, in December, and like in one way I think it would be cool to do Advent of Code after going through all these languages, and then kind of like choosing different languages, not necessarily a new language every day, but like considering like, what would be a good language to do this challenge in, you know, and then kind of like leaning on some of the things that we learned in November for Advent of Code. But in the other way, it's like, if everybody's doing Advent of Code, is it actually interesting for me to do Advent of Code? I don't know. Like, should I be the one person not doing Advent of Code so people have a break? You know, it's not like my stream's large or anything, but it's just kind of like, I don't know. Obviously, it just matters what I want to do, but I don't really know what I want to do yet. I really want to do the language thing. That one's pretty easy. I don't know what else I want to do. Thanks for the like, Dylan. Okay. Real time Twitter checking. Because your Anthony writes code and insane at SQL. Yeah, I think that would be really fun. I am actually pretty good at SQL, but I don't think, obviously I'm probably not at his level. Like Postgres has insane stuff. Like we wrote an enum for a query one time and created this whole enum that we then joined all these columns on, and it was like for efficiency reasons. You can do so much crazy shit in Postgres. Sadly, my current job does not use Postgres. Very sad. But yeah, that's what I'm thinking of doing next. Let's see, tomorrow we have this family thing, so I don't know if I'm going to stream. If I do, it's going to be short, and so I doubt I will start on this language thing. But maybe I'll just say November is the language month, and I'll just jump into that, and then that will give me time to study up on graph data structures and stuff like that. I haven't played a lot with graphs and matrices. You can write Rust functions in Postgres. Yeah. That's hilarious. I did it in SQL. See, I get this function, and then I interpret it. That would be funny. But what was I gonna say? Yeah, and then that'll give me a chance on my own to kind of like figure out the whole graph and matrices stuff, which I haven't done in a long time. And then, you know, when I get back into data structures, we'll probably do graph and matrices, probably in Rust. Get back into Rust that way. I think that would be cool. It all depends, you know, like there could be some big job changes coming up. Who really knows? But that's kind of the idea. I shouldn't have any job changes for the next couple months at least. But, you know, we're potentially getting acquired. So who knows what could be around the corner, when or if that happens. But yeah, thanks for hanging out. I think I'm good for today. Let's find somebody to raid. Appreciate everybody being here. If you don't already follow the stream, send me a follow. We're gonna do a bunch of kind of a tour of programming languages. Thanks for the follow, TV Josh. Oh, I missed the follow. Wah wah wee wah wah. Wow, that's quite the username. Yeah, so I think tour of programming languages is next. That's my thought. We'll see what happens. Let's see. There's some like ALF special event, and it's pretty freaking awesome. If there's nobody actually like interesting to raid, I might raid that. But if there's somebody interesting, I will raid like an actual person that could benefit from our raid. But it's hilarious to watch ALF. I don't know if it's like international though. I don't know if it's only for the US. Okay. Let's see. I don't remember who this person is. Corey J.A. For some reason I follow him. He's writing TypeScript. Well, that's not the best idea. Okay. Let's see. I'll move this over here. Let's see who there is. If anybody has a suggestion, let me know. Anybody streaming Rust besides me? No. What about any other Emacs people around? It's a random way I find people now. Emacs, just me. Son of Viking? I don't know this one. Sad Mad Lad Salmon? I don't know that one too. I've never rated Lana before. I don't actually follow her, but I just feel like her audience is probably not all that interested in the sort of thing that I do. But it is like, you know, of course, like a big audience. Let's see. Anybody doing anything interesting? I don't even see those two people on on software and game development that you guys called out. Oh, there he is. Son of Viking. Feeling kind of off. All right, this dude is feeling kind of off. Yeah, because he didn't put Rust in his tags. Of course he's feeling kind of off. All right. Yeah, we'll give this guy a raid. Sounds good. We'll just bless him with our huge viewership. Make his entire day. It's gonna go. It's just gonna change everything for him. He's gonna suddenly have a great day once we raid him. But anyway, thanks so much for being here, and I'll catch you guys most likely tomorrow, if not Tuesday. So, well, Tuesday's Halloween. Okay, it might actually be Wednesday. We'll find out. We'll find out. I'll be back soon. All right, see you guys.